So at the request from a student, I was asked to explain composition of functions in a little bit more detail. When I would be in the classroom, I would start out with an example of if you go to one of these stores like Kohl's or Boscov's, and sometimes you get multiple discounts. And you'll look at the ticket price, and for example, it'll be $100, and you get 15% off, which 15% off of 100 would give you $85. So you started with the 100, took 15% off and got 85. And then you may have a second coupon that gets you another 20% off. And 20% off of the 85 now gets you down to $68. So it's these guys are thought of as functions where you have a domain value you start with and you plug it into a function. This is subtracting 15%, which is the same as taking 85% of the value. And so your domain value is 100. You plug it in and the value coming out is your range. But what happens now is that range value becomes the domain for a new function. You plug it into that second function, and now you get a second range value coming out. And again, this idea is called the composition of functions. Okay, we are applying more than one function to values. Composition of functions is going to be written like this, and it's going to be read f of g of x. And the easiest way to remember this is sort of the same idea as what was up above. I'm going to take the x value, plug it into the g function, and get a value. I'm going to then take that value and plug it into the f function. So let's say, for example, I have two functions here. The first one, f of x, is x squared. The second one, g of x, is 2x minus 1. And I'd like to find f of g of 2. Well, the first thing I'm going to do is rewrite it as f of the function g of 2. So what do I need to do? Well, the first thing I need to do is find what g of 2 is. I take the 2, plug it in for the x. 2 times 2 is 4, minus 1 is 3. So now this g of 2 is actually going to be replaced by the number 3. And I'm going to take f of 3, plug it into my second function. This simply says to square it, which gives me a 9. So f of g of 2 would in fact equal 9. Let's take a look at another example. If I have f of x equals 2x minus 1, g of x equals x plus 1 over 2. Let's see what we have. I have f of g of 3, which is going to be f of g of 3. I take the 3, plug it into my g function. 3 plus 1 is 4, divided by 2 is 2. So this guy equals 2. I plug 2 into my f function. 2 times 2 is 4, minus 1 is 3. Another example. F of g of 5 becomes f of g of 5. If I plug 5 into my g function, 5 plus 1 is 6, divided by 2 is 3. I get f of 3. I take the 3, I plug it into this function, my f function, 6, and I get an answer of 5. Something really interesting is happening here. I start with 3, I ended up with 3. I started with 5, I ended up at 5. What really is going on is if I took f of g of x and rewrote it as f of g of x, that means g of x, which is x plus 1 over 2, is now going to get plugged into my f function. And when I plug it in, I get 2 times this value, x plus 1 over 2, minus 1. The 2's cancel. X plus 1 minus 1. I end up with x. What happens is, no matter what value I would start with, when I go through the composition of functions, I'm going to end up with that same value. And what we come up with when that occurs is these guys are inverses of each other. So if you ever hear of inverse functions, that's what we're talking about. Real quick, staying with the idea of inverses, how do I find a function's inverse? Inverse notation is written as f to the negative 1 of x. So if I start with this, I'd like to find its inverse. Well, the way we find inverses, we take away f of x and write y. Y equals 2x plus 1. Now to find someone's inverse, I switch the x with the y, and now I solve for y. I'm going to subtract 1, going to divide by 2, and I get y equals x minus 1 over 2. This process gives me what we were just referring to as this is the inverse. So whatever value I plug into here, a domain value, I get a range value, I plug it into here, it's going to come right back over to here. Okay? So just a real quick video explanation of composition of functions that dribbled over a little bit into conversation about inverses. Hope it helps.